We are doing section 4.6. I think, personally, this isn't that hard. There's actually a couple things we're going to do in this lesson. There's a couple things we're going to do in this lesson that we've actually talked about before, but we're kind of unofficial on it. I don't know. Do you remember me saying something about this is free of charge, and you're going to learn this later, but I'm telling you right now. Okay, well, this is later. All right, so you're going to officially learn this stuff today. Now, let's get a triangle. Let's grab... let's see. Do I have an isosceles triangle here? Let me scooch this over. That's kind of isosceles, it looks like. All right, so let's put that here. Let's just kind of twist it so it looks like that one in the book. So we'll twist it. Let's get it straight. Oh, it's not straight. Oh my gosh, I'm gonna be here all day if I keep doing that one. That's close enough. Oops. Let's. Come on, come on. Is it? I don't think it's ever gonna be straight. That's okay. That's good enough. Okay, here we go. It's supposed to be an isosceles triangle. What's that, Jacob? Believe it? Yeah. Okay, it looks good enough. All right, here we go. What if I did this and I did this? What kind of triangle is that? It's isosceles because you got two sides, at least two sides equal to each other, so it's an isosceles triangle. All right, here's the deal. When we talk about an isosceles triangle, the angles that are opposite the equal sides, you see the equal sides, obviously, don't you? You see the angles that are opposite those equal sides? Thank you. These angles right here are called, they have a name, and they call them the base angles. All right, so this angle right here and this angle right here are the base angles. They're the ones that are opposite the equal sides. Does that make sense? All right, so these are the base angles. This angle up top here is not opposite the equal sides. It's opposite the non-equal side, and we call that a vertex angle. I really doubt I'll refer to those all that often, but you never know. Maybe in a problem in the book or something, they may say, you know, the base angles, something about the base angles, okay? And in fact, I believe, forget that. All right, so anyway, that's that. That's vertex angle. Let's see, base angles. Oh, the two sides that are actually equal to each other, we call the legs of the isosceles triangle. Now, this only happens when you have an isosceles triangle. Or if you just have a scalene triangle, just any old, you know, triangle without two equal sides, you just call them the sides. But if you have an isosceles triangle, then the two sides that are equal to each other are called the legs of the triangle. Make sense? Yeah. Equilateral, I don't think you'd call any. You just call them the sides. All right. So if you only have two sides equal to each other, you call the two equal sides legs, and I guess you would call this the base. I don't see in here where it says they call it the base. It doesn't really matter. Where does it say that? Do you see it? Oh, they sure do. Right in the picture. My goodness. I was looking at the paragraph where they were describing this stuff. Yeah, they do. So I was right, wasn't I? Yeah. They do call that the base. All right, so that's a leg, and that's a base. All right, no big deal. What are we concerned about? We're not concerned so much about what we call these sides and angles. Okay, we're concerned about the equality of these things. All right, so if this side is equal to this side, here's the first theorem. This is a theorem that says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if I have these two sides equal, then the angles that are opposite, do you see this angle right here? It's opposite this side. So that's going to be equal the angle opposite the other equal side, the other leg. So that means I could put a little arc right there. Do you follow me? So I've got, let's label this, A, B, C. The angle, if I have an isosceles triangle, I got two equal sides, right? So the two angles that are opposite across from, right, those two equal sides are going to be equal to each other as well. So if this side is equal to this side, this angle equals this angle. That's what it's saying. You get it? All right, so if the two sides are equal, the two opposite angles. I don't want to just say the two angles, because look, that's an angle right here and that's an angle, but does that mean that this angle and this angle are equal? No, the base angles. So since we've named these things base angles, if I have an isosceles triangle, what can we say? Real short, we can say the base angles are what? Come on, are congruent or equal to each other, okay? So if I have an isosceles triangle, the base angles are going to be congruent or equal. Make sense? Now, they don't say it like that. They get a little bit more wordy. Again, it's on 283. They call it Theorem 410. They even give it a name. They call it the Isosceles Triangle Theorem. Let's write that down. So isosceles. Remember how to spell isosceles? I-S-O-S, isos, and then what? Celes, C-E-L-E-S. Okay, isosceles triangle theorem. That's what we call this. And what does it say? If I have an isosceles triangle, then what's true about the base angles? They are congruent. Okay? Make sense? Pretty simple. We also have, we've done this before, I don't know so much in this chapter, we've done it in other chapters where we actually have the converse of it. Do you remember the converse? Yeah. So what does the isosceles says? If the sides are equal, right? Let me put this. If the two sides are equal, then the what? We'll say it like that. The base angles or the two, yeah, let's not say the two angles. Let's say the base angles. Sorry, I'm kind of writing over across this. So if the two sides are equal, then the base angles are equal. That's what this theorem says. What do you think the converse of the isosceles, spell it out, I guess, isosceles triangle theorem? Say it.
The base angles are equal, then the two sides.
Very good. If the base angles are equal, then, skip down here, then the what? Then the two sides, or actually, let's not say the two sides. Let's say the what? The opposite. How about say the opposite sides are equal? It's basically saying the same thing, okay? Are you with me on that? So if the base angles, watch, if I was given that angle A equals angle C, what could you say? That's all you knew about this triangle, is that angle A equals angle C. What could you say now about that triangle? The two sides are equal. So what are the two sides? The opposite sides are equal. AB must equal what? CB. Everybody get that? So if I'm given that angle A equals angle C, so if I have a proof, right? And they say angle A equals angle C, and you're like, man, it'd be nice if I got those two sides equal to each other. Well, now I can say it, can't I? So if I got the two angles equal, now I can say that these two sides are equal, and what would be my reason for that? Converse of the isosceles triangle theorem, okay? Or if you want to write it out, I had another book where we didn't really call it the isosceles triangle theorem. We would just write out if the sides are equal, or what did I say? Oh, I know how we said it. We shortened it up. We said it like this. We said that the opposite angles of equal sides are equal. Does that make any sense? The opposite angles of equal sides. So if I have equal sides, bang, bang, they're equal, right? The opposite angles are what? Are equal as well, right? How could I write in a short form like this the converse of that? Opposite what? Sides of equal angles are what? Are equal. That's how I used to write it in my other book. They didn't really give it a name like this, but in this book they give it a name, so we can call it this. All right. So if I'm given the two sides are equal, why can I say that A and C are equal? Because of the isosceles triangle theorem. You with me? To tell you the truth, I don't know, some geometry teachers may hate to hear this. If you want, I'm okay either way that you just say isosceles triangle theorem. Does that make sense? All right, so I don't care if they give you the two angles and you have to find the two sides. You can use this as a reason. If they give you the two sides and you want to say the two angles are equal, you can use this as a reason. I know technically that's not correct, you know, because the isosceles triangle theorem says if the two sides are equal, then the base angles are equal. And some geometry teachers might freak out if they heard this, but I'm okay with that. All right, that makes it easy for you, doesn't it? All right, so you don't have to write all this stuff out. If I give you these two sides, why are A and C equal? Isosceles triangle theorem. If I give you the two angles equal to each other, why can you tell me that AB and CB are equal to each other? Isosceles triangle theorem. Okay, so you don't even have to say the converse if you don't want to. I'm okay with you just saying this. I know what you're thinking and what you mean. Make sense? All right. Now, you'd be right. It wouldn't be wrong if you said the converse of it. But if you just want to say isosceles triangle theorem every time for either one of them, I'm completely okay with that. All right. Let's move on. All right. Let's take a look at this. I tried to make this triangle so all the sides are equal to each other. So what kind of triangle is this then? Equilateral triangle. Now, technically, you could just call this isosceles because isosceles is at least two of the sides are equal. Are at least two of the sides equal here? Yeah, but we save the word isosceles, at least in my class, for triangles that just have two equal sides, okay? So we'll call this equilateral. Now, we talked about this earlier. This is one of those times where I said later we'll show it for real, but this is the time that it's for real. It says, this is a theorem, again. Actually, they call it a corollary. Isn't that weird? You haven't even heard that yet, have you? Have you heard that before? Corollary. A corollary, basically, it's kind of like a theorem, but it's kind of underneath a theorem. There's like this hierarchy. You got this big major theorem, and then under the theorem is a corollary. All right, a corollary has to do with the theorem we just talked about. So it actually has to do, because look, I'll show you. This is a little mini proof. If these two sides are equal to each other, what's true about these two angles? They're going to equal each other. Agreed? Okay. Look, if this side and this side are equal, what's true about these two opposite angles? They're going to be equal. So if that has one arc, what's this going to have? One arc. So we just did a proof right there. Isn't that cool? That's why it's a corollary, because it has a lot to do with the theorem we just talked about. Does that make sense? All right, it's kind of like a little underling theorem. So what do we have? If I have an equilateral triangle, so if I have an equilateral triangle, must be also what? Okay, so if it's, we'll say this, if it's you know what? I'm going to do it. I'm going to show you a little different thing. If it's equilateral, then it's also what? Equiangular. Good. Equiangular. All right. And I'm going to put a little arrow and have arrows go in both directions. It's kind of if-then statement that goes both ways. So if it's equilateral, then it's I'm sorry. Did I say lateral? Yeah. If it's equilateral, then it's equiangular. You could also say what? If it's equiangular, then guess what? It's going to be equilateral. Do you see that? That's why the arrows go in both directions. All right, so there you go. If it's equilateral, then it's, so if all the sides are equal, that means automatically all the angles are equal. If all the angles are given to be equal, that automatically means all the sides are going to be equal to each other as well. That's pretty easy to see. We've also talked about this. What about the sum? What are the sum of all the angles of a triangle? What do they add up to? Right, 180, right. Now, if all these angles are the same, let's call this x, let's call this x, and let's call this x. So if I add all three angles together, I get 3x. And what do they equal? 180. So what is each angle? 60 degrees, okay? So each angle on an equilateral triangle is 60 degrees. Each angle on an equiangular triangle is always what? 60 degrees. So you just memorize it, all right? And, you know, we figured it out. That's 60 degrees, and that's 60 degrees right there. We good? Do you remember talking about that earlier in the year? It might have been even this chapter. I don't know. I can't remember exactly when we talked about it. Yeah, it was. That's right. It's when we talked about the sum of the angles, right? So we did talk about it, but now this is official. All right, now that's the official thing right there. All right, we're pretty close to done here. All right, so here we go. We've got a triangle. I'm given that this angle is 120. This side, the length of this side is 11 whatever centimeters we'll call it. And these two angles are equal. I'm given those two angles are equal to each other. Travis, what would you be able to tell? I tell you what, let's label it so that we have some reference here. All right, Travis, what would you say? Good. Yeah, that's the easiest thing to see, isn't it? So line AC is also 11. How do you know that? Give me a reason for that. Good. Isosceles Triangle theorem. Very good. Okay, so there you go. All right, what do you think, Jaden? 30 degrees. Now, how'd you get that? That's right. So 180 minus 120, all right, because I take this away, let's find out what those add up to be. That would be 60 degrees. So are they both 60 degrees, though? No, they're both equal to each other. So what can we do with that 60? Divided by what? 2. And so each of those angles is 30 degrees. Very good. So that's 30 degrees, and angle A and angle B are both 30 degrees. Make sense? Can we find length AB? We can? How? Let's think about that. Somebody want to dispute that? It's only for right triangles, okay? You can only use a squared plus b squared equals c squared for right triangles, okay? It's a good guess. Do we have time?
Nope.
No, we don't either. We got like 30 seconds. We could actually figure this out. I think we're still missing a theorem, but we will eventually be able to figure out line AB, line segment AB. All right, just not today because we've got to show you another theorem, and I don't want to show you that theorem. We'll wait till we get to that. All right, very good. Let's put a homework assignment up here. All right, here's the assignment right here, page 287, 288, 9 to 24. There are two proofs. 23 and 24 are proofs. Do your best on those.